Hello, Professor. So, I'm going to try to get through these two labs here. I've got a lot of stuff. I will be sending you two pictures. I did do my diagram for the kinetic lab, and I did do my bar graph. I apologize about this. I'm not a real good grapher on Excel. I tried for about an hour and I couldn't get it the way I wanted it, so I figured I'd just pin it, and hopefully you would accept that. But I will send those to you again in an email form. So we'll start with the first one, the ice cream. It was I was actually getting quite excited about eating some ice cream. I remember my grandfather making it this way when I was a kid. Only he had a big pail, ice around it, metal can in the middle, put some ice or salt on it and spin it around. 10 minutes later, we had homemade ice cream, churned ice cream. It was delicious. I was looking forward to finding a new way to do this without having to buy one of those contraptions. But it didn't work out for me. I was not able to get the solution to change state from liquid to solid or semi-solid. The solution would start out endothermic, which we wanted. The salt bath, the ice and salt bath solution would turn out to be endothermic, which means that it would go from the system, which was the milk, sugar, and vanilla solution. That was the system, and the surroundings was the salt bath. The energy would be transferred from the salt bath into the milk solution, therefore freezing it, changing its state from liquid to solid. I don't know if you want me to read you all my findings. The temperature of the ice was at 0 degrees Celsius. The milk was at 11 degrees Celsius. When I added the sugar and the flavoring, and then I took the temperature, it had jumped up to 12 degrees Celsius. I'm attributing that just to the room temperature, milk being out and me doing that. Once I added the salt to the ice, it moved to negative 1 degree Celsius. Temperature of the milk after shaking for 1 minute was 6 degrees, so it did start to drop rapidly. However, when I got to the second temperature reading at 2 minutes, I was at the same 6 degree Celsius mark, and therefore I recall reading your announcement saying that sometimes you have to add more ice and salt to it. So therefore I did, and it did start to take off again after that. By minute 3, it had dropped down to 2 degrees Celsius, so it had dropped 4 degrees by adding that extra ice and salt. Temperature after 4 minutes dropped all the way down to negative 4 degrees Celsius. I thought I was on my way, but at the 5-minute mark, it had gone back up to negative 2, so I had lost 2 degrees on it. It had become exothermic at that time. Temperature after shaking 6 minutes, it had gone to negative 3, and then at that point I added more ice and more salt, and it dropped back down to negative 4, negative 5, then back up to negative 4 and negative 3 by the 10-minute mark, and it never did turn to a solid. It was just ice cold milk. So I'm not sure exactly what I did wrong, or if it was just a bunch of variables that I couldn't account for, like the humidity in the air, the humidity in the room. Was I shaking it too hard? Was I not shaking it enough? Was I not exactly sure what went wrong there? But once it had started to go exothermic, the reaction with the empathy of reaction not quite reaching equilibrium, the reaction could never make it to its equilibrium state, therefore turning its state to a solid. Let's see. I talked about the system. What was the system? What was the surroundings? So therefore, I think I'm done with that one. Now I'll move on to my notes on the Kinetic Lab. So after 15 minutes, I took the test tube out of the refrigerator. It was registering at 8 degrees Celsius. The hot after going into the bath, and I brought the temperature of the water up to 100 degrees Celsius, took it off, put my test tube in the beaker into the water, let it set for 15 minutes, and I got my temperature of 38 degrees Celsius when I ran my experiment. Room temperature was 21 degrees Celsius. I had 12 centimeters for a diameter on the balloons. Deflated, uninflated balloons was 12 centimeters across the board. My cold was at 16 centimeters. My hot was at 17 and a half centimeters, and my room temperature was at 18 centimeters. This would make sense to me, seeing how our enzyme was yeast, a living, breathing entity. When it's taken out of hibernation, it's going to react as a catalyst with the temperatures. I'll just read my notes here. With the extreme temperatures of the hot and cold compared to room temperature, the enzymes were denatured in the hot and cold experiment. At room temperature, it was not. Because the molecules were preoccupied by the temperatures, the enzymes had to wait its turn to react. I believe this is why the circumference of the balloons at room temperature was greater than the others. With the yeast being being a living organism, it only makes sense that the cold would have a lower reaction, kind of put it back into a dormant state, so it's not going to really catalyze anything. It's not going to really do much of anything until the temperature slowly warms up and it gets to go to work. Same thing with the hot. It needs to be brought down to a certain temperature before it would start to react and create a large amount of gas and CO2, taking the oxygen out of the peroxide, the H2O2, and converting it into a gas that would fill the balloons. Did everything go as planned? No, not for the ice cream one. For the Kinetic one, yes, I think it did go as planned. I kind of figured that the temperatures would stifle or excel the process. It seemed to shut it down, the temperature variance, because enzymes seem to work better at body temperature, closer to body temperature, 98 degrees. Oh, and my safety. Sorry, my safety. Same as always, glasses while I'm working with the experiment. My fire extinguisher is always in my kitchen anyway, underneath the sink. My exits were cleared and accessible. I just had my daughter in my house with me tonight, and she knew I was doing my experiment, so she stayed in her room and out of the way of getting anything to go wrong. Everything is pourable down the drain, and I had smoke detector. When I was doing the ice cream, it did get very, very cold, frosty cold. And that's saying something with a guy that lives in South Dakota. It got very cold. I was kind of surprised that it did not change states into an ice cream. So I did have to handle that carefully so I didn't get frostbite. That's it for today, or for this week. Hope you have a good week, and we'll try this again next week. Bye, Professor.